Hey guys, welcome to today's video. If you're new here, be sure to subscribe and check out some of my other videos. And if you're already subscribed, welcome back. Today we're going to be learning about the periodic table of elements. It's fairly simple, but it's important that you understand it really well because it's the basis for everything else in chemistry. Let's get into today's lesson.
Here we have an empty periodic table. This is the modern periodic table, and it's arranged in order of atomic number. If you don't know what atomic number is, I've explained it in my past videos, so you can pause this and go back to watch those if you need to. The rows, which are being labeled 1 through 8, are called periods, and the columns, which can have 2 labels, are called groups or families. The elements in these groups tend to have similar characteristics, but I won't get into why that is today. Some subgroups that you may want to know, however, are alkali metals, which is in group 1 or 1A, alkali earth metals in group 2 or 2A, halogens in group 17 or 7A, and noble gases in group 18 or 8A. Now, there's 3 main categories in the periodic table. Metals, which are being outlined in blue and take up the majority of the periodic table. Nonmetals, which are being outlined in green, and metalloids, which are being outlined in red. Some elements in the periodic table tend to have properties of both metals and nonmetals, but they can't fit into one category. Those are what we call metalloids. Now, let's take a look at all the elements in the first 3 periods on the periodic table, because you'll see these elements often in lessons like my own, so you will need to know them. First, we have hydrogen. This is the first element in the periodic table since it has an atomic number of 1. The rest of the elements follow in number order. Hydrogen is what makes up stars, like our own sun. Next is helium. This is found inside many balloons to keep them afloat. Then comes lithium, which you can usually find in batteries. Beryllium can be found in the form of emeralds. Boron gives off a green color when burned, so it can be found in fireworks. Carbon is the stuff of life, and most people associate it with coal or diamonds. Then we have nitrogen, which makes up 78% of the Earth's atmosphere. Oxygen, as you probably already know, is the air that we as humans breathe. Fluorine is in our toothpaste. Neon is obviously found in neon lights. Then we have sodium, which is in salt, and magnesium, which is in chlorophyll, giving leaves their green color. Then we have aluminum, which is used in utensils. Silicon is found in sand. Phosphorus is found in our bones. And then there's sulfur, which can be found in eggs. That rotten egg smell actually comes from sulfur. Then we have chlorine, and as many people know, it's used to clean pool water. And the last element in this period is argon, which is used in light bulbs.
You can see how just these few elements have a wide range in uses and make up many of the things we use daily. These elements also have many more different uses, and the elements we didn't cover also play a vital role in our lives. 1 minute, let me go check on that sound. Archie, keep it quiet, I'm trying to record a video.
Oh, sorry, I'm just trying to weigh these dolls so I can put them in order from lightest to heaviest.
Why?
Why not?
But you do realize that that's the lightest and that's the heaviest. You could pretty much just put them in size order and it's the same thing.
Oh.
But anyways, that does remind me, I'm gonna need these dolls.
But I need you to right.
Mendeleev created the earliest periodic table. We don't use his model today, and we've expanded upon his first 63 elements, but his model does shed light on the relationship between atomic number and atomic mass. Atomic number, as you may recall, is the number of protons in the atom of an element. The periodic table that we use today is set in that order. 1 proton to 2 protons to 3 protons, etc. Atomic mass is the mass of the nucleus in an atom of an element. Mendeleev set his table in order of atomic mass by essentially weighing each element, just how you saw Arjun doing. Scientists have compared the two tables and found that they're almost exactly in the same order. This shows that there is a strong correlation between atomic number and atomic mass. But it makes sense, doesn't it? The one with the least number of protons is going to have the smallest core and be the lightest. And the element with the most number of protons is going to have the biggest core and be the heaviest. So what did we learn today? We learned that the periodic table is set in order of atomic number. We learned that the rows are called periods and the columns are called groups or families. Groups tend to have similar characteristics. We also went over the first 3 rows of elements and looked at what they're usually used for, although they have many different uses, so you don't have to worry about memorizing those. Lastly, we looked at Mendeleev's periodic table, which is set in order of atomic mass, and looked at the relationship between atomic mass and atomic number.
Please like, share, comment, and subscribe for more videos every week.